Okay, so good morning. Good morning, everyone. This is the master thesis defense by David Mateo Carpio, supervised by David Sanchez and Jose Ramasco. The title, How Interactions and Connectivity in Social Media Networks Mediate Language Use. David, the floor is yours. Do not go beyond half an hour.
Okay, so welcome everyone, thanks for coming. This is my master thesis, How Interactions and Connectivity in Social Media Networks Mediate Language Use, which was done under the supervision of David Sanchez and Jose Ramasco. This is the outline of the presentation. So let's start. In a social linguistic context, it has been proposed that linguistic similarities reinforce personal bonds, while individuals adapt their linguistic behavior according to the characteristics of their social networks. This results in a feedback loop in which language use influence social interactions, and social interactions in turn shape the language use. This feedback loop is a central problem in social linguistics, as everyday exchanges are the primary mechanisms through which linguistic variants are transformed, transmit, and reinforced. In this aspect, online social media provides a unique opportunity to explore this problem, as they generate vast amounts of data in both social interactions and the linguistic content that they produce in the reality. Previous research has demonstrated the link between language use and social influence, where socioeconomic, cultural, geographical, and even political factors has been related with the linguistic behavior of the individuals. Despite these insights, a detailed study of how personal social networks directly influence language use remains relatively unexplored. To this end, we use Twitter data. As we know, Twitter is a microblogging platform where users can share short content message, commonly referred as tweets. Each tweet provides a set of metadata features as the ID of the author, the text, the created ad timestamp, the place ID, and if the tweet is a reply, it also includes the ID of the user being replied to. Overall, we work with more than 500 million tweets. All of them are geotagged, so we have some location information, which could be a place in the format of a boundary box or coordinates when they are available. Overall, all the location corresponds to the United Kingdom. We focus on this particular country, first because on Twitter, it has been detected a linguistic diversity, also a consistent between standard and non-standard forms of language, and finally, because it's one of the countries with the highest per capita Twitter usage. All the tweets were published by around 4 million users, but not all of them are of our interest, so we first apply a pre-processing step, where we remove non-relevant users for our study. First, we filter out accounts that contains 2 consecutive tweets implying velocities higher than those of the plane. We remove those users as we interpret them as shared accounts. We also remove accounts having a non-human tweeting rate, where on average they have more one tweet per hour during the whole activity period. This because that behavior is related with one of the bots. We also remove users having less than 10 tweets. This because we don't have enough information for a meaningful analysis. And finally, we remove users that didn't have at least 1 sequence of 3 consecutive months with activity. This because we aim to characterize residents of the United Kingdom and avoid characterize transit visitors such as tourists. Then we remove around 3 million of the users. For the rest, we try to assign a set of residents. To do this, we draw first a regular grid of square cells, each measuring 25 kilometers square. Then we compute the numbers of tweets published by the users in the cell, and we assign the residents to the cell that contains most of the tweets. So Okay. Okay, so let's continue. Here we detect different we use different methods for detect communities in the network. We use Oslo, Infomap, and Ruben. We keep the communities detected by Oslo because they give us a larger number of communities, especially in the scale of 100 of nodes. And these are of particular interest, and this scale is consistent with the Dunbar's number, approximately 150, which corresponds a cognitive threshold for maintaining stable social relationships. So with all these elements, what we aim to understand in this work is how social interactions between online communities mediate both the languages employed and the prevalence of non-standard linguistic forms. So let's start exploring the network that we use for this, the reply network that we construct, which contains 1.1 million users, 10 million edges, and the tweets belonging to the network publish around 300 million tweets, where 10% of them correspond to replies. These are some metrics of the network where we see that the reciprocity of the links are around 17%. Also, we see a slight tendency to form triads, as we can notice by the clustering coefficient. We also calculate the average in and out degree, which is 9.4. Nonetheless, we find clear difference between the degree distributions of the in and out degree. Here we have the two cumulative distributions, where the black one corresponds to the in degree, where we notice that few users receive many replies from many others. Few users receive replies from many others, while users do not tend to reply to a large number of distant users, as we can see in the out degree distribution. Now let's focus on the communities that we have detected. Here we have the cumulative probability of the size of the communities, where in total we find 10,000 communities, where more than 5,000 contain at least 30 nodes. In what it follows, we focus on that communities for statistical robustness when we calculate the different metrics. The cumulative distribution expands up to around 12,000 nodes. So as we can see here, we have a large variety of communities in the scale of 100 nodes that we are interested on. Now, to examine the spatial distribution of the communities, we do this for get more insights about what is happening in these communities. Here we determine if the community members are segregated in specific regions of the United Kingdom, or if they resemble the spatial population of the complete reply network. To do this, we consider the air mover distance. The air mover distance measures the minimum cost required to transform one spatial distribution into another. In our case, we compare the spatial distribution of the community members of a given community K with the spatial distribution of the complete reply network. Here we have the results for the EMD values for the different communities. Here is the distribution, where low values means that the spatial distribution of the community members follows the complete network spatial distribution. Then this peak corresponds to communities that are segregated in specific regions of England and Wales, and this other peak corresponds to communities that are mainly segregated in Scotland and Northern Ireland. Here we have two quick examples where this corresponds to a low EMD value, where we see that the spatial distribution of the community resembles the one of the complete reply network. On the other hand, the upper one corresponds to a community with a high EMD value, where we notice that the community is segregated, in this case, in Liverpool. Now let's move towards the analysis of the languages. Here are the distribution of the tweets per language and also the distribution of primary speakers per language. As expected, the vast amounts of tweets and primary speakers use English. We have also, we refer English as the dominant language of the country, of course, and we refer the other language as the minority ones. Arabic and Spanish stands out as minority language. Nonetheless, they just account for less than 1% of the primary speakers. Here we have the spatial distribution of those speakers for Arabic and Spanish. We have also added the case of Welsh. This language is of particular interest, as it is a regional language of the United Kingdom. Now, the idea is to see if these primary speakers of minority language are interacting. To do this, we consider the communities that we have constructed. Here we measure two things, the fraction of replies in a given language L, and also the fraction of nodes sharing that language as primary one for every community K. Here we plot the communities that either the most commonly used language in the replies is a non-English language, or the most common primary language among the members is other than English. In total, we find 64 of such community, representing around 1% of all the communities. Here, the x-axis corresponds then to the fractions of nodes sharing that minority language, so that high values of this fraction means that the members of a community are almost all sharing the same minority one. As in this case of an Arabic community, where we see that almost all the members use Arabic as primary language. We define this community as having a marked social identity in the sense that they are using Arabic, although they are residents of the United Kingdom. Also, we have a presence of family, as they prefer to interact with the similar peers that also use Arabic as a primary language, although they are in the United Kingdom. Then the y-axis tells us the fraction of replies in that language. For example, here, almost all the replies are given in Arabic. But now, another interesting phenomena to analyze here are the departures from the diagonal to a position above it. Here, the interactions in the given language is greater than what would be expected if the user just only used the primary language. This indicates an adaptive behavior where individuals shift from the primary language to use this minority language for interacting with members of the community. This is the case of this Welsh and English coexistent community, where when they are interacting inside the community, they prefer to use Welsh. As we see, most of the half of the interactions are in Welsh. Then we also compute the air movers distance for those particular communities. Mainly, we find that the Welsh community is the most segregated, as expected, because they are localized on walls. For the Arabic ones, which corresponds to the half of the set of the minority language speakers, we see a diverse behavior where some of them are segregated, but as we can see here, most of them are dispersed across the United Kingdom, and some of them follows the spatial distribution of the complete reply network. Now, let's move towards the final analysis, which is the analysis of non-standard language. Here we focus on the English corpus, where we have around 200 million tweets, and we find 9 million non-standard features. The frequency of non-standard features per 100 token is 0.3. These are the top 10 of the most frequent rules that has been not obeyed. But now the idea is to see if the use of non-standard features is related with the formation of the communities. To do this, we first compute the frequency of non-standard features of the users, and then we compute the average frequency of the members belonging to a community K, which is represented with this capital F nodes. Here we compare with a null model. So we create a null model where for each community K, we generate a synthetic counterpart by sampling the same number of members from the overall pool of users. Then we compare the two distributions of these capital F nodes. Here we have the results, where the yellow one corresponds to the null model and the blue one to the one of the data, which corresponds to the reply network. Here we see a higher number of communities in the high frequency values, which means that communities are formed by members who use non-standard features more frequently. We also have the same case in the low frequency regime, where we find communities formed by members sharing standard language usage. The lack of these communities in the null model tell us that they cannot be formed by chance. So that this gives us a hint of homophily in the way that that users prefer to make connections with similar peers. In general, The conclusion here is that users with similar linguistic behaviors tend to cluster together and form the communities. Now we see the effects in the internal communication. The previous one was for the overall, we consider the overall frequencies of the members of the community, but now we consider the internal communication. Here we measure the frequency of non-standard features in the replies of a given community K. Here we have the distribution of this metric F replies for the communities, where higher values means that the communities are using more non-standard language in the internal interactions. Then we plot the two metrics, here in the y-axis, the internal communication given by the F replies, and the x-axis corresponding to the average behavior of the users that belongs to the community, F nodes. Each point corresponds to a given community. As expected, these two quantities are correlated, but also the linear fit tells us that there is a slope greater than 1, which means both things joined means that communities composed of members who frequently use non-standard features, when they interact, they reinforce and amplify the use of these linguistic practices. Then, to account for the statistical fluctuations inherent to the data, we calculate this sigma, and the shaded regions accounts for the statistical fluctuations inherent to the data. And those communities located above the shaded regions are those in which the use of non-standard features is particularly reinforced. Finally, to analyze how the members of a community change the behavior from the overall content to the internal content, we define this radio, where we define the metric F replies over F nodes. We also account the sigma prime for considering the statistical fluctuations inherent to the data. This radio will be the one in the case that the users are having the same behavior in their overall tweet production and the internal cases, in the internal communication, which is the expected behavior. Then the communities lying above the shaded regions are the communities in which there is more non-standard features in the replies than what is expected. On the other hand, the communities lying below the shaded regions corresponds to communities in which the communication inside the community has less non-standard features than in the overall production of the members of the community. Overall, we find that there are more communities in the upper part, but we have also the effect that some members of communities change to a more standard language when they interact. So there are the two effects, but the most pronounced is the one to increase the number of non-standard features when they interact inside the community. Now, the final part, and what actually it is ongoing work, is to see what are the social factors that are shaping this non-standard language usage within the communities. Here, we first try to use the air moving distance values that we calculate for the communities. Nonetheless, as we can see here, it accounts, the Pearson coefficient is low, which means that the spatial distance alone accounts only for a limited fraction of the variation. This opens the question, and is actually for future work, what are the social factors that are influencing the behavior of the communities for using non-standard features? Overall, in this work, we have used tools from network science combined with language analysis, and we have demonstrated that online social interaction not only reflect, but also shape the linguistic practices. Also, we find during the presentation, communities with a marked social identity and high presence on homophily as they cluster primary speakers of the same minority language. Other communities, in contrast, exist adaptive linguistic behavior where individuals shift from using their primary language to use a minority language when interacting within certain communities. Similar mechanisms appear in non-standard English. In particular, the interesting one was that homophily and adaptation to the social context amplify the use of non-standard language. As mentioned, for future work, what we aim to understand is what social factors are contributing to shape the non-standard language within the communities. In this aspect, for example, include economical variables, or analyzing the internal topics that they are talking about could give signs of this. We can use, for example, latent Dirichlet allocation or even large language models to explore what are the contents of the communities, and even what are the dialects that are talking in the communities. So I hope that you have enjoyed the presentation, and of course, if you have any question, please continue.